Good afternoon, students. In the earlier class, we have started set theory and we discussed about a finite set and an infinite set. A set which has finite number of elements is a finite set, and the set which has infinite number of elements is an infinite set. Let us continue our discussion today about set theory. We also discussed about empty set in the last class. Empty set is also called as a null set or a void set. It is a set which has no elements. Then a singleton set is a set which has only one element. Now, there are different ways of writing a set. Writing or expressing a set. Now, the first thing is we must show the set using a capital letter, and we always use a curly bracket to show a set. Now this is a set A or this is set D which I have written. See how I have written. D is equal to X such that these two dots, or sometimes they draw a vertical line. It means such that is a prime number which is divisor of 60. Now this form of writing a set is called as set builder form. So, how is it written? X such that X is a prime number which is divisible, which is a divisor of 60, divisor of 60 or a factor of 60. Now, we know factors of 60. Now, this is my rough work. So, 1, 60. 2, 30, 3, 20, 4, 15, 5, 12, 6, 10, yes, 7, no, 8, no, 9, no, 10 we have already taken. All these are factors of 60. But this set does not contain all the factors of 60. It says a prime number which is divisor of 60. Now from these we have to pick up prime numbers which are the elements of this set. Now if I have to pick up the prime numbers, we all know that 1 is neither prime nor composite. Of course 60 is also not prime. 2 is prime, 30 is not, 3 is prime, 20 is not, 4 is not, 15 is not, 5 is prime, 12 is not, 6 is not. That is, this set contains only 2, 3 and 5. They are the elements of this set D. That is 2, 3 and 5. The prime numbers which are divisor of 60. So, they are the divisors of 60 and also they are the prime numbers. Now, 2 is an element, 2 is called as an element of this set or member of this set. 3 is also an element of this set. 5 is also an element of this set. So, what we write is number of elements in D. This is the way to write. Number of members in D is 3. There are 3 elements. Now, this way of listing the elements of a set, this is called as a roster form of writing a set. That is, a set can be written in two forms. First is set builder form and then second is roster form. These are the elements of the set. This set has 3 elements. This is a finite set. It contains the prime divisors of 60. Right? Let's go to that question now. X is an integer. Minus 3 less than x less than 7. Now you want only there are infinite numbers otherwise between minus 3 and 7. But you want integers which are between minus 3 and 7. Now they have not taken equality. So minus 3 is not included. Also understand this is the set builder form of writing the test set. Now A minus 3 less than x less than 7. So you will have minus 2, minus 1, 0, 1, 2, 3, 4, 5 and 6. 7 is also not included because they have said minus 3 less than x less than 7. 7 is not included. This is set builder form. This is the roster form of writing a set. Now this set has 3 and 3 6 and 3 9 elements. So how we write number of elements in A is 9. So when you have a set, it can be written in two forms, set builder form and roster form. Set builder form can be converted to roster form. Roster form can be converted to set builder form. Here I have taken a set which is written in roster form and I want to write it in set builder form. Now this is a set, say A, 1 by 2, 2 by 3, 3 by 4 and so on. What you all must observe is denominator is 1 more than the numerator. So I have set X which is of the form P by Q such that Q is 1 plus P. Yes, it contains numbers of the form P by Q such that Q is 1 plus P and also P is from 1 to 6, right? So I'll write 1 less than or equal to P less than or equal to 6. And also P and Q both belong to natural numbers, or you can even say positive integers, right? So this way it's set builder form. Listing the elements is the roster form. How I have written? X contains all numbers of the form P by Q such that Q is 1 plus P. But then what is P? P 1 less than or equal to P, that is P is from 1 to 6 and P and Q both are natural numbers. Now this is roster, this is set builder form, this is roster form. Some of you may even write this as P by P plus 1 such that 1 less than or equal to P less than or equal to 6, P belongs to N. I skip Q and directly write P by P plus 1 or X by X plus 1. You all observe that denominator is 1 more than the numerator and use that. Now this and this both are same and both are fine for this. That is, we understand that a set can be written in set builder form or in roster form. Roster form means listing the elements. Now, when I list the elements, suppose I take this set again, 2, 3, 5. The order of the elements does not matter. Like I can write this as 2, 5, 3. It is one and the same. Right? I can write this as say 3, 2, 5. It's one and the same as long as the number of elements and the elements are same. It is one and the same. So the sequence of members or elements in the set does not matter. It does not change the set. Also understand one thing. One element is written only one time in a set. Suppose I form set say P, which is set of letters of the word say school. Yes. Now I want set of letters of the word school. So what this is set builder form. I will write it in roster form now. It contains S, it contains C, it contains H, O and L. I will not write O 2 times because one member, one element is to be written only once in a set. School contains 2 times O, but when you list the elements, it will be S, C, H, O, L. And that is how a set is to be written. So all of you work on the basics of all these: finite set, infinite set, null set, singleton set, then set builder form, roster form, elements of a set, right? And complete your exercise 1 and work even from the reference book and see that you get the clear concepts of set theory. Thank you.